So we'll open it up for questions in just a second, but I just want to conclude by sort of looking forward. And John, in the sense of the NHL or even the NFL, do you think that this is something that they really are seriously looking at, or do you think they're just saying what consumers want to hear? Because right now concussions are out of style. And then for the two of you, for your research, I'm just curious what are the exciting things on the horizon that you think are going to move things forward? I'm sure the in vivo is one of them, but.
Yeah, well, I'm a journalist, so I'm cynical by nature. I think what we've seen with the NFL the last 5 or 6 years, and what we're starting to see with the NHL, which is kind of following the same arc in a lot of ways with head injuries, is that it's a public relations issue and an economic issue. The NFL didn't start paying attention a whole lot until I think maybe 18 or 19 brains had been examined and found to have CTE. And when they realized that there was a lot of momentum behind the science and behind public perception of it, they said, oh, well, yeah, won't we sit down at the table with you guys and start talking about this? The NHL is not there yet. The NHL says, we don't have enough samples. We don't believe this is the issue. We're going to let people continue to fight. They think they've done enough. But they're building lawsuits. They're building class action lawsuit in Minnesota that now has a few dozen former players that I'm told will soon have a couple hundred former players lining up against the NHL to say, I'm retired and my head's not feeling right, and what are you guys going to do about it? And so I think at that point, there'll be a tipping point of some sort when it becomes a public relations issue for them.
So I am optimistic. I think that there's a little bit too much fear right now, and that we will learn, although it's going to take a long time, that some of the activities that are very healthy for our children to be involved in sports, soccer, I'm hoping some extent football up to some level. Certainly the NFL is risky. I'm hopeful that we'll find that these things aren't as bad and it's not as scary as we think, but that's going to take a real long time. Some of the things that my lab is working on in terms of, understanding the biomechanics, I do think that there's a possibility for, and I used to be more pessimistic, but the more I'm learning, I'm becoming optimistic, that improvement in equipment and rules, if done properly, can help. And also for, we're talking about these organized sports that are kind of the big money, in this country, but, bicycle riding is the #1 cause of sports and activity-related concussion in children. And I think the bicycle helmets could easily be improved. So I think that there's hope.
I think that there's methods being developed now that are going to significantly improve our ability to understand what's going on with a patient who's suffered repetitive head trauma well before they have to go to pathology, fortunately. So there are a couple of imaging techniques that have been proven to be particularly helpful. One of them is using PET scans, and there are now these compounds that bind to this tau molecule so that you can put someone in a PET scan and actually quantify how much tau there is in the brain and what parts of the brain it tends to be more heavily distributed. Now this again is going to be this will be sensitive to tau, we think, and again it's still very, very experimental, but we've started using it in players as well as some of our other patient groups who have tau-related neurodegenerative diseases. So we're very excited about it. The other is more advanced imaging techniques using magnetic resonance imaging. The typical MRI scan that everyone goes in when they have knee problems or shoulder problems or after a head injury, because there are some techniques that are more sensitive to even microscopic disruption of the fiber tracks that connect the different parts of your brain. And we do know that in patients who've suffered even a single mild traumatic brain injury, that you can see evidence for these kinds of changes shortly thereafter that eventually do resolve. But so we're coming up with better markers of some of the imaging changes. And then of course neuropsychologists always take the brain out for a test drive and look at memory, look at impulse control, look at language skills, look at concentration and attention. These are things that can be disrupted following acutely or chronically. So so these are some of the directions in which folks are headed. I think that over the next 5 to 6 years, we'll have a better sense of if someone might have chronic traumatic encephalopathy whilst they're still alive. And I think even more importantly, start coming up with some protocols to reduce the risk of this happening in the first place.
I think there are microphones in the back of the room if anyone wants to ask a question, just so that everyone can hear the question. I saw someone raise their hand.
Do you have to stand up and do it?
Yeah. Correct.
Hi, you mentioned protein folding earlier. I'm wondering what, if any, relationship is there with prion disease, aka Creutzfeldt-Jakob or mad cow disease?
So on one hand, there really isn't any relationship with Creutzfeldt-Jakob disease or prion disease. On the other hand, there are people in the neurodegenerative disease world, including Stan Prusner, who won the Nobel Prize for figuring out these whole prions, that a lot of diseases operate like prions. So prion is basically a protein that gets misfolded, and you get that protein next to another normally shaped protein, and it will cause the normally shaped protein to misfold. So it spreads like that. That's how it propagates. And you know, a lot of us, me included, think that that's how a lot of these neurodegenerative diseases spread. And one of the models for chronic traumatic encephalopathy is that, you know, these head injuries, you know, cause some shearing in these fiber tracts. That tau, which is an important normal part of these fiber tracts, you know, leaks out, hyperphosphorylates, misfolds, and then it's in the system, and over time it makes other tau proteins more likely to misfold. That's, again, just one of the theories or models that, that's going on. But again, there are, you know, a lot of people do think that these diseases have a prion-like effect. But it's not like a prion disease where people have these horrible symptoms and die within a year.
Well, take one.
You talk about the traumatic brain disruption, the brain sloshing back and forth a bit in the skull. Can you describe in a bit more detail what is actually happening and what sorts of damages? In other words, it's kind of a general idea, but what's really happening to the neurons, to the interconnections? Can you give us some more sense of that rather than just that it's sloshing or been deaccelerated too fast? What's the real damage?
Right. Yeah, I wish I could. You know, I'm asking the National Institute of Health to help us come to some answers here, because honestly, there isn't, we don't have a detailed understanding, and that's why I speak in vague terms. I would say the most detailed understanding we have is from computer simulations of what's happening inside of the brain, and then possibly some animal studies. So the prevailing theory right now, we don't understand the details of how this happens, is that you know, the white matter in your brain, so the gray matter is on the outside, the white matter is on the inside, and the white matter is the wiring that kind of connects all the computation. And the white matter is actually reasonably organized in the sense you've got a bunch of wires all running in the same direction. And as force translates, I'm being vague, from the skull into the brain, the thought is that these axons and fiber tracts get stretched. And when they stretch, there's some kind of reaction that happens, and we don't know really what it is, and that's what causes the trauma. And the other notion is that it actually has to be pretty diffuse to cause concussion, not just a single little small point, a single axon or a single fiber. It needs to be spread through a large fraction of the brain in order to cause deficits. But this is all very vague. We don't really understand the physics very well, nor the biology.
Thank you.
Next. For people who've had multiple concussions and there's an autopsy, do you find that the lesions are inside the brain, or are they primarily on the outside surface of the brain? And do you find that, let's say somebody's had 10 concussions, you're likely to find 10 different places in the brain where there's evidence of that? Or they tend to recur in the same place?
So the tau deposits tend to be, or certainly inside the brain, they tend to, in chronic traumatic encephalopathy at least, they tend to cluster around some of the vessels, blood vessels. They tend to be deep in the sulci. Early on, they tend to be in the sort of the anterior part of the temporal lobes. So there tends to be sort of, not a semi-characteristic distribution of these tau aggregates. Is there, you ask an interesting question, which is, if you get 10 hits, are you going to find 10 different regions? And the answer is no. And what we also don't know is if there's any kind of close relationship between how many hits you've had and how much pathology you had. That's not at all clear.
For Professor Camarillo. It seems to me that the protection that headgear might provide is pretty much a lost cause because, like you said, if you get hit in any part of your body, your head and brain is going to experience acceleration, and your brain is going to be sloshing around and suffer the consequences. So, I mean, I don't see how headgear can really help the general case where you can get hit any place on your body.
Yeah, so there, indeed, you can sustain concussion and brain trauma without any head contact. So this is kind of like a whiplash type injury, and these happen even you can see them in the NFL if you watch, and probably in hockey as well. Somebody will get hit in the body and whiplashed. So there, this is a good thing. We have ethical standards at universities that have improved over time. In the 60s and 70s, there were animal experiments carried out on primates that you certainly could not do today, where they inflicted trauma and tried to understand a little more of these details. One of the more famous experiments was done with these whiplash on monkeys, and this was actually demonstrated pretty clearly that if you put a neck brace on the monkey so that their head they don't get the whiplash, it actually does indeed prevent the trauma. So maybe a helmet is not the solution, but there still may be interventions that you can take to reduce the head acceleration that then leads to the brain trauma.
Thank you. Frankly, I feel kind of odd about asking this question. I find it a little embarrassing. I've heard this discussion for, I think, the last 30 years. I think there's more data has been collected. One of my questions is, exactly how much data do you require before you come to the conclusion that this is really a no-brainer? I mean, seriously. You've already told me that in many ways. What appalls me about it is the fact that this is really a contest between science and culture to a large extent. And it's okay, it's going to continue on. I've heard another 5 years we might get there, and I'm not sure what we're going to learn anymore that we don't know at this point, which is really the culture has got to prevail, because that appears to be the contest in this area. And the part about it that I can't reconcile is that this is promulgated to a large extent by medicine, science, and the educational institutions that, to a large extent, that benefit by this and frequently support the research. At what point does anyone want to get up and say, this is really a very dangerous thing. There must be other ways to do it. I say, oh, well, would that mean, God forbid, giving up these particular sports? Well, I think that's a grown-up issue that has to be faced in a lot of ways. And I think it puts everybody on the hot seat to a certain extent. So I'm pretty much convinced at this point, I'm not going to wait another 30 years to find out that it's really, really bad. I've got that right now just by coming into this auditorium and hearing from medicine, science, all of the institutions that are involved. So where do we go from here? Which is, we really have to confront the question. And we all know what the question is. That's the end of my soliloquy. I leave you with that. I leave you with that.
I thought you were going to talk about the fashion issue of athletes wearing neck braces.
You kind of take a quick stab at a non-answer to a non-question. It is interesting, and I love this question because you're right. It's a big cultural issue, and at what point does the culture say enough? And I think what's happening in hockey and some other sports is that we're seeing the grown-ups in the room, the proverbial room here, say, wait a second, what about the kids? It's one thing to have professional hockey players beat each other up, but what about a 16-year-old kid in Canada, which they do? And we're starting to see some rules now, for example, in hockey, or some rules in soccer saying, maybe we don't know enough, but these are kids, and we have a public safety issue here with children. And I think we're starting to see, for example, in hockey, some of the rules in some of the leagues for kids, and I say kids, they're 16 to 20 years old, they're adding penalty time, for example, for fights. And some leagues have actually gotten rid of a lot of the fighting now. They see it as a public safety issue for the children. And I think we'll start to see that percolate up. The big question will become, do we care about protecting guys who are willing to do it when they're professional, when they're making $1 million, when, we still have boxing. We all know it's not good for you, but there are people willing to do it. At what point does the culture flip and say, we're not watching anymore? So that's my soliloquy.
The only thing I would add is that, I think it's fair to say that violence is a part of human nature, and that's probably not going to change, and that's reflected in our culture and the entertainment. And so, I think people are willing to take risks, even known risks, even as we learn and the science gets better.
Yes.
And,
sorry.
Sport, walking out of the house, you take some risks. These sports that we're talking about are not just putting your brains at risk, they're putting your neck at risk, you're putting your knees at risk, when we're talking about sending our kids out to play these sports, I think every parent has to make a sort of a judgment call about how much risk is too much, and to what degree do the risks, to what degree are they balanced by the benefits of participating in team sports or physical activity. And I think that a better knowledge base for truly understanding what the prevalence of some of these disorders are and what the risks are is going to be a very important part of the process. So I think that we don't know all the answers yet and require a lot more thinking about it.
Okay, I mentioned earlier, I think, I just want a clarification of the possible connection between head injury and sleep apnea. And then secondly, in terms of concussion in early 20s and then mid-70s, memory loss. Connection there from your studies?
So the sleep apnea comment was more because these guys, these large football players, are at greater risk for sleep apnea. Sleep apnea can cause attention, concentration, cognitive problems.
Yeah.
So it was just used as an example of all the different confounding factors that make it difficult for us to know in vivo, before someone has died, whether or not the symptoms they present with at age 65 are related to the putative head injuries they had when they were in their 20s and teens.
But sleep apnea is a possible ramification of that?
Well, it's not caused by the head injuries.
I see.
It's just one of the many other factors that people get when they're older that can affect cognition. Just like, if you take a sample of 70-year-olds who used to play football who are having some symptoms, not all of them will be having cognitive symptoms because they have chronic traumatic encephalopathy. Some will actually just have garden variety Alzheimer's disease. Some will have frontotemporal dementia. Some are having symptoms because they have some substance abuse issues. Some will be having symptoms because they've had so many physical injuries. They have chronic high levels of inflammation, or they have a big body mass. They're overweight and they have vascular risks. So there's so many different things that could be going on in our brains as we age. And it's kind of hard to definitively link things that were happening in their teens and 20s to the clinical presentation in their 70s.
All right, thank you.